All right, in this problem, we're looking at dilution, right? And what does dilution mean? It usually means you're adding additional solvent to a pre-made mixture. And so in this question, it asks, chemist makes 740 milliliters, 3 significant digits, of sodium carbonate solution by adding distilled water to 270 milliliters of a 0.684. So what we have is, we have exactly 270 milliliters of this 0.684 molar solution. And then this chemist adds enough water to bring it up to 740 milliliters. Now we've added no additional, remember, molarity is moles per liter. It's counting how many particles are in there per liter. We have added no additional moles, but we have added water. So it's just become more dilute or less concentrated. So this is a chemist concentration unit, is molarity. And so if you had a blue solution, it would become more light blue, or a red solution would become light red, right? So we're diluting this solution and we got to figure out how much. And lots of different ways to ask this type of question. But the key is we use this M1 V1 equals M2 V2. And the key to this formula is making sure you have the right things in the right places. So I would see this as volume 1, because I started with 270 milliliters, and this as molarity 1. And then I have volume 2. Now here it tells me the total solution. What you need to be careful with is if it says a chemist added 300 milliliters, volume 2 would not be 300, it would be the 300 plus the 270 original. So be careful with that, with how it's worded when you do problems like this. Is it being added or is it the new total solution volume? And in this case, it's the volume. So we're gonna plug these in. 0.684, it's in the right units. I'm going to just stick with milliliters because I'm going to cancel them. Now I could convert that to liters, but I don't have to. With the M1 V1, it could also be C1 V1 equals C2 V2. So that equals 740 milliliters times M2. So to solve for M2, I'm going to divide 740 over here, both sides. And so I'm going to do 0.684 times 270 divided by 740. You'll see my milliliters cancel and I'm left with molarity. Now it's become less concentrated. So my gut check tells me this number should be smaller than 0.684 and I get 0.24957. I'm going to cut that off at 3 significant digits, which rounds up. So it's going to be 0.250. And this 0 is significant because it's after a decimal point and a whole number. And so we have 3 significant digits with 0.250. Let's plug that in. For our molarity. There we go. So what did you start with? Or sometimes it reads with the final, like I have a solution of 0.25 molar, that's 740 milliliters. What was the original concentration if it started with 270 milliliters? And you could go backwards. Now it doesn't really matter what you call 1 and 2 as long as you put the right units together when you use the formula.